Hi, my name is Hajar Arif. I am an MSc student from University Tun Hussein of Malaysia, UTHM. I am currently studying industrial statistics. Today, I want to present about the study my team and I have been doing and may it spark even a little bit of interest in knowing more about the field of study we are currently doing.
So these are the team members from UTHM, included me, from UUM, and from UNIMAP. This study is entitled Solving a Mathematical Model Through Chi-Square Test on Queuing Problem in General Hospital. The contents of this study starts from introduction, literature review, methodology, result and discussion, and conclusion. Queuing. The truth of life is we have faced this queue almost every day in many events, such as at queue at post office, drive-through fast food, and hospital services. And it is always desired by the management team of the service providers to reduce the length of the queue and the waiting time of the customers. The first step before queuing system analysis can be performed is the determination of the distribution pattern of its two main parameters, which are the arrival rate and the service rate. And there are many methods available for the testing best of fit of distribution pattern, but out of it is chi-square test, where it is considered as the most efficient and easy method for testing the nature of queue and service provider. Sufahani and Ismail 2014 state that there is a limited numbers of research that has been done involving hospitals in Malaysia, especially government hospital. In this research, the study was conducted at a hospital in South Peninsula, Malaysia, and as far to our knowledge, there is no report of research for this hospital. We move to the methodology. The methodology starts with data collection, formula for data estimation, and fitting goodness of fit. The data was collected through observation at a government hospital in Johor, Malaysia. The name of the hospital cannot be disclosed due to the term and condition in collecting the data. And the data consists of two parts, which are arrival rate of patients to the hospital and service rate. For the data estimation purpose, the formula for estimation rate is x hat equals to n over summation of ti, where n equals to number of patients in the system and t equals to inter-arrival time or service time. The method for fitting goodness of fit starts with break up the set of inter-arrival times and service times into k categories. The data is divided into at least 5 categories to ensure each category can be as close as possible to the value of EI. And the breakup of categories is shown in this figure. Secondly, the cumulative distribution function is determined to set the category boundaries, where the cumulative distribution function equals to 1 minus exponent x hat p. For any number p, the value of satisfying cumulative distribution function equals to p is 1 minus p equals to exponent xt, and then taking algorithm to base E yields, where we get p equals to ln 1 minus p over negative x hat. Third, under the assumption that function t does govern the inter-arrival times, to determine the number of the TIs which are expected to fall into category I, and these numbers are called AI. And the fourth, we count how much observed TIs in category I, and these numbers are called OI. And the fifth step, we compute the observed value of chi-square statistics using this formula, and then the hypothesis of this test is written as follows. Therefore, we can conclude that hash null is accepted if chi-square observed is equal or less than chi-square critical value, and accept hash null if chi-square observed is larger than chi-square critical value. In this study, there are two main parameters which are arrival rate and service rate. Therefore, the result is presented for these two parts. Now we will go through for the arrival rate first. These are the inter-arrival times, and we determine the inter-arrival estimation rate as 0.0195 arrival per second, and then the value of cumulative distribution function for inter-arrival is 1 minus exponent negative 0.0195t. And since the cumulative distribution function of the inter-arrival is 1 minus exponent negative hat t, we get that 1 minus p equals to exponent negative 0.0195t. And then taking algorithm to base E yields, we will get this. And therefore, the categories of inter-arrival times is divided into 5 categories, and we get function t equal to 0.0195 exponent negative 0.0195t. And then the chi-square observed is computed, we get 5.2. We choose alpha 0.05 and r is equal to 1 to get the critical value, which is 7.81. And since the chi-square observed is smaller than the critical value, we can say that the hypothesis is accepted that inter-arrival comes from an exponential distribution. Okay, now this is the service rate, and we applied the same method as arrival rate to service rate. Okay, this is the data of the service time. We get the service estimation 0.0011 service per second, and then the cumulative distribution function for service is 1 minus exponent negative 0.0011t, and the service time you get 1 minus p equals to exponent negative 0.0011t. And then taking algorithm to base E, we will get this one, and then categories for service time, the same 5 categories, and where the function t is equal to 0.0011 exponent negative 0.0011t. We compute the chi-square observed and get 5.3 and critical value 7.81, and then you can say that hypothesis can be accepted that service times comes from an exponential distribution since the value of chi-square observed is smaller than the critical value. And at last, we go to the conclusion. So based on the results, it was found that both inter-arrival and service rate follows an exponential distribution, and we suggest in the future work we should involve real inter-arrival and service times of healthcare data with normal distribution or Erlang distribution. And that is how chi-square test related to queuing. Thank you.